We will continue with the second exercise for 3D rendering, which will be fused PET-CT rendering. A combination of surface rendered skeleton from CT with volume rendered PET is pleasing for PET-CT data. VOIs can still be added as in the previous exercise, and elements of the skeleton can be trimmed away to reveal details from the PET. For example, the top of the skull can be trimmed to reveal trace uptake in the brain. We start by opening the 3D tool, and we'll work with mouse 6 from the Bruker PCI database. In this case, we have the pre-processed data where the bed hardware was masked out of the CT data, so we should use the CT whole body crop masked dataset, and we need a PET dataset that has been co-registered and resliced to the appropriate resolution. For this we have the PET whole body crop masked resliced dataset, which was obviously cropped. The bladder was masked to avoid it dominating the rendering, and then it was resliced to the same resolution as the CT data. So add that for loading as well, and we will load the CT and the PET together. On the segmentation tab, we'll start by rendering the skeleton from the CT, and then we will return to render the body of the PET. In this case, we use the same method as in the last exercise. So we have the CT selected on the input tab in the top left. We can see the images available using the drop-down menu below the information button, and we start with the CT crop masked. Segmentation with a threshold will be suitable for the skeleton, and we can use the same fixed threshold of 500 Hounsfield units and then run the segmentation. We can still turn on the MIP as in exercise 1 to see that our rendering will really represent the skeleton. Then we can add the segment to the segments tab in the lower right, and for this new segment we can then set the 3D rendering properties. For the skeleton we will render surface. We will set the color to white. And we can use the clear name skeleton. Then we can confirm 3D rendering properties and render the selected segment. In this case, as from the previous exercise, we see quite a reasonable rendering of the skeleton, and on the View tab in the top right we see the entry for that part of the rendering. Now, to add the PET data, we can return to the Segmentation tab. In the top left, on the Input tab, we can use the drop-down menu to select the PET data. And then we can use threshold-based segmentation to extract information for the whole body. In this case, we can use a threshold of 5 units and run the segmentation. As you can see on the current tab in the top right, we include voxels from the whole body, excluding background and excluding the bladder. So once again, we add this segment to the Segments tab. We see the new entry appear below the skeleton segment. We can select that and again change the 3D rendering properties. In this case, we will use a volume high definition. We will use the cold color table, selected from the menu that opens, and we can change the segment name to PET. Now we should make sure that this volume rendering for the PET is appended to our display. So we make sure that the pin icon to the left of the Render Selected button is pinned in, and then we can render the PET by selecting it from the segments list and using the workflow button. Initially, the rendering of the PET volume is dominated by the background activity throughout the body, and we don't really see into the rendering to the higher activity in organs like the kidneys and heart. We can adjust this by adding transparency to the volume rendering. To do that, select the VR PET on the View tab in the top right, and then the Volume tab in the lower section on the lower right. The transparency can be adjusted by entering a value in the transparency box highlighted here, and we can enter a value of 0.5 and press enter to update, and then wait for that to have an effect on the rendering. Then we can additionally adjust the upper threshold of the profile range, seen below the color transfer function, to approximately 80%. Again, waiting for the effect to be seen in the volume rendering. This renders the high activity areas more clearly. Now we can explore the image using the mouse and left click and drag. And we see that we better see the kidneys and heart. We see the lesion on the right flank near the ribs, and we can see high activity in the skull and head area. To highlight the lesion on the right flank, we can add the volume of interest. To do this, we go to the Input tab, where in the lower right we can select the VOI from the database. We have an entry for mouse 6 tumor, and we will set that as the selected VOI. Then we can render it as a surface. Without additional smoothing. And we see the VOI appear in the rendering as in the previous exercise. In this case, we can add some transparency to the VOI as well by selecting the VOI in the View panel in the top right, and then the VOI tab in the lower section. We can move the transparency slider again to approximately 50% and view the effect on the transparency of the VOI surface in the display. Finally, we will trim the top of the skull to reveal the PET tracer uptake in the brain and the Harderian glands. To do this, we should add a plane by selecting Planes on the View tab. Then on the Planes sub-tab, we can add a plane, in this case using the oblique plane. The plane is loaded in the display, and an arrow is seen running through it. We can use the arrow as a control to rotate the plane and find the orientation that we want to use for cutting, and then we can move the plane before applying the cut to a specific area. Rotate the rendering until we can see the top of the skull clearly. Then click on the tail of the arrow and drag that to adjust the angle of the plane. This process may be somewhat iterative. Try to rotate the plane to such an angle that you can imagine it cutting through the top of the skull without cutting away everything else. Once such an angle has been achieved, then we can click on the plane itself and drag it along the body until it transects the skull. Now, to apply the cutting, we should select the segment that we want to be cut, in this case the surface rendering of the skeleton. So on the right, on the View tab, we can select Surface Rendering Skeleton. Then we have a sub-tab Cut. Here we want to make sure that the cut is on the top side of the plane as seen on screen, which means not on the arrow point side. By default, that checkbox is normally activated. We should make sure it is deactivated and then apply the cut using the cut button. Immediately we see part of the surface rendering disappear, and now we should hide the cutting plane to view our final rendering. To do that, we can select the plane that was created on the View tab, and on the Planes sub-tab we can uncheck the Visible checkbox, and now we see our rendering with the skull cut open, revealing the activity that we want to see. So now we have our complete rendering. We can explore it with the mouse as usual and start a rotating movie. In that case, we select the Scene tab, the Rotation sub-tab. If we want to capture the movie, we can activate the Film Strip button, and to just play the movie, one of the play buttons.